In this tutorial I will show you how to make this effect with animation nodes and Blender 2.8. If you've never used animation nodes before, you might want to watch a beginner tutorial first. This is more of an intermediate and upwards tutorial. That being said, let's get straight into it. Okay, so we have a fresh scene here, so let's go ahead and replace the default cube with a text object. And let's write animation nodes like that. And I'm gonna use this font called Righteous. It's from Google Fonts. I'll link to it in the description. And let's change this to center and decrease the line spacing a bit. That's looking good. So what we need now for this effect is we need two versions of this text object. One that's like this, the original one, and one that has a bit thicker letters, something like this. So we'll duplicate this so that we have two objects, and we'll hide the first one for now. And let's make this second one a little bit thicker with this offset value. Sometimes there is points where the letters don't quite work out, but usually if you play around with this you can get it to work. And we need to make both of these into curve objects to be able to get the splines out of them in the animation nodes. So let's do that first. For the original one, you just go up here to the object panel and convert to curve. So now it's a curve object and we can use these curves in the animation nodes editor later. But to make this second one into a curve object, we actually need to do some tricks, because if we just go here and convert to curve like the last one, it'll actually make it to a curve using the original curves, and then it does the offset thing again. And we actually need the curves to be on the outside of these thicker letters. So what we need to do is we need to first convert this into a mesh like this. So now it actually uses the correct outlines without any tricks. And then we just convert it back to a curve object like this. And now we have the outlines. We lost the fills there. There's now only these outlines. If you want the fills back, you can make this into a 2D curve and then change the fill mode to something else there. But we don't actually need the fills really. I'll actually change this back because it's easier to see that way. So now we have both of these done, and we can actually go to the animation nodes editor. So just go here and choose animation nodes. Okay, so let's create a new node tree. Shift A to add new nodes, and we'll go straight into it and add an object input node. And let's duplicate that to get two of them. And let's actually change the names of these text objects to make it easier to identify which one is which. And we'll put them here, original and offset. Next we need the splines from these curve objects. So spline and get from object. Let's put two of them like that. And let's first work on this original object here. In the final effect, it's the letters that don't glow. And basically what they do is they get gradually trimmed in by a controller object. For that we need a way of trimming the splines individually. And to do that we're going to use a loop. Let's go here to subprograms and let's add a loop. Let's put it here. Loops are basically just a way of repeating a set of instructions multiple times. What they are most commonly used for is going through a list of items, like the spline list here, and performing some task for every one of them individually. In the curve object here, every continuous outline is one spline basically. So the letter A has two splines, the letter N has one spline, etc., etc. To use a loop, we need to first define what the loop is going to do. And that's what this node is for. Let's first set up the basic structure of the loop, and I'll then quickly explain what it actually does. So let's add a new iterator. We'll use a spline list because we have this spline list here. And then we need an output for the loop. It'll also be a spline list. And for now we can simply connect these and maybe add a frame for the body of the loop by pressing Ctrl J. We can rename the frame here by changing this label. And then we need to actually call the loop that we defined here. So invoke subprogram trim loop. And we'll put it here and connect the spline list here. And then we'll take a spline object output node here and connect the spline list to there. So what we have here now is we take the splines from the object, which is this selected one here, and we feed those splines into this loop, and this loop will do some things to the splines, and then we will output those splines from this loop to a curve object output node, which will host the final trimmed splines. And this spline list input here is the iterator that we added here. And as you can see, this is a spline list. The socket is a bit transparent, as you can see here. But this here is a single spline. So this invoke node is where we feed a list of things to the loop. And this right here is the body of the loop, where we can define what to do for the individual items of the list. Right now it doesn't do anything, it just goes from the input to the output, but we'll add things to this later. But first we need to actually enable the splines from the curve output node here. And let's also create a new object for the trimmed splines. This button automatically creates a new target object for the curves. And so we can hide these original ones because now we have this newly created target object here. So now we can actually start to do stuff for the splines. And I already mentioned that we want to trim the splines, so let's get a trim node from here and add it to the center here. And as you can see, if I adjust this end value, the splines get trimmed. It's as easy as that. Let's also enable the bevel depth, maybe 0.01 for now. Now it starts to look like something. Of course, this alone would have been easier to do without the loop. What we're going to use this loop for is to make these letters appear at different times, sort of from left to right, as you saw in the final result. And for that, we're going to need a controller object. So I'll go here and add a single arrow. Put it there and rotate it like that, and maybe lock the Z and Y axis so that it only moves this way. And we will use this controller's X location to drive every individual spline's trim end value, if that makes sense. So we need to get the X location of this controller in the loop. And for that we can use a parameter. So we can add a new parameter from here. And the location is basically a vector. Let's call this controller location like that. So an iterator is basically a list of things, and the loop will take a single item from that list one at a time and do stuff for it. A parameter, on the other hand, stays constant for every iteration of the loop. So it can also be a list, but it will be the whole list for every iteration of the loop. So that's the difference of an iterator and a parameter. And when we added this vector parameter here, it also appeared here. So now what we can do is we can take the controller object from here and add a transforms input node and feed the location of the controller object to the loop. So now we can use it from here. So a vector is basically just three number values together, and we can use a vector separate node to only get the X value, and we can feed that to the trim end value. So now when we move the controller, nothing happens because I forgot to enable the always execute option from here. Now when we move the controller, we can see that the splines get trimmed with this controller, but they still all appear at the same time. So what we need is we need to know the location of every individual spline so that we can sort of offset the trimming. And we can do that by adding a spline info node and connecting the spline there. So from this spline info node we get all the points of the spline, basically a vector list. And then in the vector menu there is this vector list math node, and we can feed the points of the spline to the vector list math and change this to average, and this will give us the average location of all those points. So then if we separate that vector and only take the X output, we can sort of offset the X location value of this controller based on the average location of every spline. So let's arrange this a little bit more clearly, like this. And then we can simply take a math node here and subtract the average location of the spline from the controller's location. And now we finally have the letters nicely showing up from left to right. So that's the first part of the effect done. Okay, next we're going to do the splines that are coming from above the letters and sort of falling down. And for that we're going to do another loop. Let's call this falling splines. And call the loop. Add a spline list as an iterator. And a spline list as an output. Connect the input to the output. And add another curve object output node. And connect this there. Make another target object. And enable splines and bevel depth. So now we have the outlines also visible. And these outlines are going to become the falling splines. Let's add a frame for these. Falling splines loop. So the idea with this loop is to convert the spline into a bunch of vector points, basically. And we can do that with this evaluate spline node by clicking this here. Now if we add a 3D viewer, you can see that we get a bunch of vector points in space along the original spline, and we can increase the number. 100 should be okay. And what we can then do is to add a create from points node from here and feed the points there and then connect it to the output. Set the radius to 1. Now we have the outside curves constructed from 100 different points. Let's hide the inside curves for now so that we can see things better. And what we'll do as well, we'll make this spline not be a cyclic spline in the beginning here. It'll just look nicer in some places when we add the falling effect later. And to make the falling effect, we will need to add points to this locations list here. So we'll add 2 points, one above the first point and one below the last point. And that way we get the nice falling effect. Now to do that we need another loop again. So we'll make another loop from here. Let's put it here and call this adding points or something like that. And then call the loop inside this loop. So it'll be a loop inside a loop. Let's take a vector list as an input. Call it points and feed the locations to that input. And the output will also be a vector list. And connect that to the spline from points node. So in animation nodes loops we get this handy index number inside the loop. And it tells us which iteration this loop is currently performing. And we can use that to check if we are currently in the first iteration with this compare node. Just feed the index inside the node and check if the index is 0, which is the first iteration. And if it is, we can then add a vector before that first vector. So we take the result of that into a switch node. And let's first assume that the condition is true and we are indeed in the first iteration. So we will add a vector list here, and we'll add this first original point as the second input in this vector list, because the first one needs to be the one that's above the original first one. So we'll do a simple vector math operation here, and we'll just take the first vector and add, say, 1 along y-axis and feed that to the first input. So if we are in the first iteration, we will replace the original point with a list that has 1 point before the original point. And that point is the one that's above the original one here. And we can feed that to the if true value, and we can output this list here. And as you can see now, all we have is those 2 vectors, 2 first vectors. So we need to add something to the if false input also. And if we just add this original point here, animation nodes will make a list for us so that this is also in a list format, even though it only has 1 element. So now we have the original spline, and in the beginning of every spline we have a point that's 1 unit higher than the original one. And then we of course need to do the same kind of thing for the last points here. So we'll just add a new comparison here. And since we now need to know if we are in the last iteration, we can use this iterations number here, which tells us how many list items there is basically in this list. And since the iterations always start at 0, we can just subtract 1 from this iterations number. And that will tell us if the index is in the last iteration. And again, we can use the result for a switch node. And if it is true, we need another vector list. And this time the original point goes to the first item, because here at the bottom we need the added item to be the last one in the list. And then we'll do another vector math, and we will subtract 1 along the y-axis from the original point. And that will be our if true input. And again, we can just connect this here to the if false. Starts to get a little crowded here, so we'll make some room for this like that. And now we have 2 outputs, and we need to decide which one to use so that this doesn't duplicate all the points. So we need yet another switch node. We connect these to the if true and if false, and if we use the result of the first boolean, we should be okay. So in the index 0 we use this group here, and in the rest of the index we use these nodes here. And I can't help but notice that something's not right. There's no lines at the bottom, and it's actually just because we forgot to subtract 1 from here. So now we have these nice falling splines that make a letter in the middle, and we can make a nice cascading trim animation for these as well. To make the trim effect, we'll do much of the same as we did with the inside curve. So we'll go here to the falling splines loop, and we'll add a trim node there. And we need the controller location in this loop as well. So we'll add a parameter here, vector, call it controller location. And then we can feed the same input from here to this other loop as well. And then we can again take a separate vector node and take just the x value from the controller location. And feeding that to the trim spline end value, we get this familiar effect. But we again need to take the average location of every spline so that we can offset the trim like we did with the inside curves as well. So we'll again use the vector list math node, and we can use this modified vector list with the added points, take the average out of them, and then separate that as well so that we get the x from there also. And a simple math operation here as well. Subtract this average x location from the controller x location, and we should get a nice cascading trim effect, just like that. Now what we want to be different with these falling splines is that we want them to disappear also when they've reached the end of their spline, so that they don't leave visible like this. And we can of course use the trim start value for that. It's very simple to do. We just take another math node here, subtract, and we take this result and subtract say 0.5 from it and feed that to the start value. And now we have these very nice falling splines that also disappear when they've done their run. And if we now unhide the inside curves, we get to see the full effect. Very nice. The only thing that's missing now is the vertical instancing. As you saw in the final clip, I had these sort of vertical instances of these same curves, and we'll do that next. One more loop basically, and then the effect should be done. So let's create yet another loop. Let's call this vertical instancer. And this time we won't add any iterators, and instead we'll just have a spline list as a parameter and as an output, like that. And that way, when we call the loop, vertical instancer, and let's say we'll first add it for the inside curves. What's different now is that we have this iterations value, And because we don't have an iterator in the loop, this loop will just take this parameter and do the stuff we tell it to do as many times as we define here in the iterations value. And this will be used to decide how many vertical instances we're going to get, basically. So let's try this out. We'll make use of the replicate spline node, and we'll change it to vectors mode. This node basically just replicates the input spline for every vector that you feed into it. So we'll make a float range, and we will have as many floats as there's iterations. And we'll use the start step mode, starting at 0, and step can be like 0.03, for example. And then we have a list of floats, in this case 3 iterations, 3 floats. And we can use those floats to make a vector list that has differing z values based on the float range node. So now we have a list of vectors, and we have the replicate spline node, and we could just do this, and we would have a nice looking effect. But what it's doing now, it's replicating all 3 splines every time the loop is run. So now there's basically 9 splines here. They are just overlapping. So what we want to do is we want to get only the list element that we need. So we'll feed this list to a get list element node, and we'll take the current index. And it would be nice if we could just feed one vector to this replicate spline node, but because it only takes a list as an input, we will have to again create a new vector list from just this one vector. But it works out quite nicely, and now the result looks the same, but it doesn't have those overlapping splines. So the result is a much less resource intensive effect. Let's add a frame for this. Call it vertical instancer. And let's add a couple more instances. And one thing I want to add is to make every iteration a bit thinner than the last one. So we'll add a set radius node here, and we'll again use a float range node, create as many floats as there's iterations, start stop, starting from 1 and ending at, let's say, 0.3, and then we can just get the list element that we need, which is the current index, and then just feed that to the radius node. And now they sort of get thinner the higher up they are. Then we can just add the same vertical instancer for the falling splines. Maybe have a little less instances. Maybe 4 here and 5 for the other ones. Let's see how this is looking like now. It's getting a bit laggy with my screen capture, but it's looking very nice. And I also had the offset of the vertical instances change in the final animation as this controller is coming from the left. So that's easy to do. We just need to modify this step value here, and maybe we can make another controller for it. Add an empty object there, make it a bit smaller. Let's call this controller 2, and let's add an object transforms input node here. Choose the controller 2 that we just created. Separate vector. Maybe we'll actually take the scale and feed one of those scale values to the step. And yeah, now it's obviously a huge step, so we'll just have to scale this down until we get something that we like. Let's actually make this bigger, because we need to scale it down so much. And now it's very easy to just scale this controller when we need to adjust the height of the vertical instances. And then we are ready to animate, which will be very simple with this setup. I'll just reduce the iterations so that it's a bit more responsive in the viewport while we animate. Make a bit more space here. Then just take the controller object and put it where it's just before any action, like there. Add a keyframe to frame 10, for example. Go to frame, let's say 150. Move the controller to where everything is finished, right there. another keyframe, change the playback mode to AV sync so that you see it real time and see if the effect is fast or slow enough. I think that looks pretty good to me. Yeah, I'm happy with that. Then we can animate the vertical offset value also. Let's take these back so we can see what we're doing. And select this controller here that controls the offset. Let's say it will be at its final position here, maybe. Add a scaling keyframe, go to frame 10. Move this controller temporarily a bit forward so we can see the offset value, maybe something like that. Add another scaling keyframe. And I think it would be good to change the interpolation a bit so that it's a bit smoother in the end, something like this. Let's see how this looks. It's quite laggy for me right now, but I think it looks good. And then we can just make this a bit more nice looking. I won't cover this in too much detail. Add a ground plane, change to cycles, make a material for the ground plane. Let's make it dark blue, for example. Add a material for the outside curves. I'll make them be a bright blue emission, maybe like a strength of 15 or something. Take the inside curves, make a material for them as well. Maybe just a regular light blue. Add some depth of field. You get the idea, just play with the visual look until you're happy with it. And the end result should look something like this. Okay, that was the tutorial. I hope you found this useful. And since this channel now seems to have a slow but steady flow of new subscribers, I just wanted to clear up a couple things. First of all, hello to all the new people and welcome. If you watched any of my older videos, you know that I sometimes like to contemplate some philosophical topics and I like to make music and stuff like that. I've gotten some disappointed comments about it, like maybe you should stick to the content, or too fast to be useful and why are you telling us something not related to 3D and stuff like that. And I get that it might feel weird if you are expecting a normal Blender tutorial and the guy suddenly starts to talk about the meaning of life or something. And I'm sure those comments are meant as constructive criticism. So thank you to those people for commenting and suggesting a different way of doing things. But the thing is, I don't really want to do that. Like, I definitely know how to make a really tight and packed Blender video with nothing else in it, but that's not the point of this channel. Some of you will already know about this, but I actually started this channel as a behind the scenes channel for the Songs for Humanity channel, which is my main channel. I actually just published a new video over there a couple days ago. It's been a long time since the last one because I found that I can't really seem to get an audience for that channel for those types of videos. I would like to make them, and I will make them in the future, but it's gonna be a long time between the episodes because I just don't know how to get the audience, and I don't want to use all my time and energy with that. And since I love doing stuff with Blender because I'm an animator, I just make these videos in the meantime, and maybe some people will find these other topics also interesting. So I don't want to limit this channel to be only Blender. There will be other stuff, music, philosophy, those things that are also very important to me. And so the idea is that maybe some new people will also find the Songs for Humanity project via this channel, via this Blender thing that has way more search engine visibility. That would be great, of course, but if it doesn't happen, that's okay because I'll just keep making videos that I enjoy making. I hope you are doing well despite these strange times that we are living in. If you are finding yourself worrying too much about things or suffering mentally about this whole situation with the corona, I really encourage you to try to take all the negativity out of your head. I read this fantastic advice about what to do if you get into a negative situation that you don't want to be in. There's basically 3 options of what to do from which you should choose. you can either change the situation, if that's possible, or you can get out of the situation, if that's possible, or third, you can accept the situation and embrace the situation, see it in a positive light as much as possible. So what you shouldn't do is stay in the situation because you can't get away from it and you can't change it, and then resist it mentally, and then suffer a lot because of that resistance. A week ago I got a really bad stomach bug. It might have been corona, it might have been food poisoning, I don't know what it was, but I was having a really bad time. And I tried my absolute hardest to not resist the situation that I couldn't get away from and I couldn't change it. I was sick and I couldn't do anything about it. So I tried really hard to see the situation in a positive light and to not resist the sickness. And I actually sort of managed to do it a couple times for short periods, where I had this pain and nausea in my stomach, and I managed to see it just as an energy stream coming from my stomach to my brain, basically. In those moments where I managed to stop resisting it completely, it actually felt okay, like surprisingly okay. But then it got really bad again and I fell back into the resistance and the suffering. But I really believe that you can get better at that sort of stuff. But I think that's enough banter for now. Again, I hope you're doing okay, and I'll see you next time.